In section 7.3, we're going to explore what happens when you have 0 and negative exponents. So to start, a to the 0 power is 1. Any number to the 0 power is equal to 1. So 5 to the 0 is equal to 1. A billion to 0 is equal to 1. Next, if I have a to the negative n power, it's the reciprocal, which means you just flip it over, of a to the positive n. So the way I like to think about this is if I have a to the negative n, that's technically over 1. So I have a negative exponent in the numerator. I can put that in the denominator and the exponent becomes positive. So for example, 2 to the negative first is technically over 1. So I can put that 2 in the denominator and it would become 1 over 2 to the positive first. For a to the n, I know that that's also the reciprocal of a to the negative n. So I kind of work backwards here. So if I have 1 over a to the negative n, I would just put this over 1. If I have a negative exponent in the denominator, I can put it in the numerator and it would become positive. The exponent becomes positive, not the number itself. So again, I'm working backwards. If I have 1 over 2 to the negative first, I can put that 2 to the negative first in the numerator, and that negative sign will go away, so I'd have like 2 to the positive first power. So what you need to write down in your notes, number 1, never leave a negative exponent in your answer. Always get rid of the negatives by moving either it to the numerator or the denominator. So that brings us to number 2 and number 3. To get rid of a negative exponent in the numerator, so in the top of a fraction, put it in the denominator and make the exponent positive. Number 3, to get rid of a negative exponent in the denominator or in the bottom of the fraction, put it in the numerator and make the exponent positive. So you're going to see this happen in the following examples. So here's example number 1. Use the definition of 0 and negative exponents. So part A says 6 to the negative second. So I need to get rid of that negative exponent. Technically this is over 1. So I know that I can take this number and put it in the denominator and the exponent would become positive. So I would put 6 to the positive second in the denominator, which means a 1 would have to be left in the numerator. So just to simplify that, I would get 1 over 36. For part B, I have x raised to the 0 power. Anything to the 0 power is equal to 1. For problem C, I have 2/3 all raised to the negative second power. So the first thing you need to remember is that when I have a power on the outside here, I just need to take the power to the 2 and the power to the 3. So I can say that that is 2 to the negative second over 3 to the negative second. Now I cannot leave my answer with negative exponents. So if I have a negative exponent in the numerator, I put it in the denominator and it becomes positive. So that would become 2 to the positive second. And I had a negative exponent in the denominator, so I'm going to put it in the numerator and have it become positive. So just to simplify that, I would end up with 3 squared is 9 and 2 squared is 4. So the final answer would be 9 over 4. And finally, for part D, I have 0 to the negative 7th power. Remember, that is technically over 1. So I would change that to 0 to the positive 7th over 1. However, 0 to the 7th power is just 0. And you cannot divide by 0, so this answer is no solution. Example number 2, evaluate exponential expressions. So part A says negative 2 to the 5th power times negative 2 to the negative 5th power. So we know that we need to keep that negative 2 in parentheses, and whenever I am multiplying, I need to add the exponents. So 5 plus negative 5 is 0, so I'd have negative 2 to the 0 power. Well, anything to the 0 power is equal to 1, so this entire problem is equivalent to 1. For part B, I have 3 to the 3rd raised to the negative second. So I have a power to a power, so I need to multiply. So now you're going to have to start thinking back to all the other properties that we've learned so far. So we would have 3 to the negative 6th, since 3 times negative 2 is negative 6. So remember, don't leave anything with a negative exponent. So I have a negative exponent in the numerator, so I'm going to put it in the denominator and make it positive, which means a 1 should go on top. And so I would just need to multiply that out. 3 to the 6th is equal to 729, so I'd have 1 over 729 as my final answer. For part C, I have 1 over 8 to the negative second. So remember, I cannot leave any answers with negative exponents. So that negative exponent in the denominator needs to go to the numerator and become positive. So I would have 8 to the positive second over 1. 8 squared is 64, and I don't really need to leave it over 1, so my final answer is just 64. And finally, part D, I have 7 to the third over 7 to the fifth. So remember, when you divide, you subtract the exponent. So I would end up with 7 to the negative second. So knowing that I cannot leave my answer with negative exponents, I'm going to put that in the denominator and make it positive. So really I end up with 1 over 49. Another way to think about this problem is that the 3 sevens up here would cancel with 3 sevens in the denominator, so I would leave myself with 1 over 7 to the second, which is just 1 over 49. So either you can think about it like this, where you actually subtract the exponents, or you think about it like canceling. 3 of the 7s up here cancel with 3 of the 7s down here, so that I left with 7 to the second in the denominator. Either way will work, and either way is correct. In example number 3, it says, is simplify the expression, write your answer, as always, using only positive exponents. So for part A, I have 3x to the negative second, y squared, all raised to the third power. So the first thing I need to do is take everything to the third power. So it's like I'm going to do a power to a power, so I'm going to multiply. So it would be 3 raised to the third, x to the negative sixth, y to the positive 6. So I just multiplied all the powers. So this 3 has a positive power, so it's going to stay in the numerator. This x to the negative 6, that's a negative power, so it's going to move to the denominator. So again, the 3 to the third is going to stay where it's at. The x to the 6th will go to the denominator, and the y to the 6th will stay in the numerator. So the last thing I need to do is just multiply out what 3 to the third is. So 3 times 3 times 3 is 27. Y to the 6th over x to the 6th. So the last thing you want to make sure of is that nothing on top can cancel with anything in the bottom, which it can't, so this would be my final answer. And now let's look at part B. There's a couple different approaches to this problem. We're going to look at both ways, but no matter what approach you take, the first step would be to reduce the coefficients out in front. So we just need to take 4 over 8 and put that into lowest terms. So 4 over 8 is 1 over 2, so 1 will go on top, 2 on the bottom. The first approach would be then to just use subtraction, since we have terms with like bases raised to some powers, and since we are dividing, we are going to subtract the power. So the first I have is x to the negative second and x to the first. So I would take x to the negative second and subtract 1. For the y's, I would take y to the fourth and then subtract 6. So just to reduce that, I would again, I don't really need to have this 1 up here, so I'm going to get rid of that 1. But I would take x, and negative 2 minus 1 is negative 3. And y to the 4 minus 6 is y to the negative second, and again there's still just that 2 down there. So I cannot leave any negative exponents in the numerator, so I'm going to move that x to the negative third to the bottom and the y to the negative second to the bottom. So it'd be 2x to the third, y to the second, and then I would just have a 1 left on top. And that would be my final answer. Another way to think about it is by, again, first just starting with that 1/2, and then just thinking about moving things. So this x to the negative second would have to be moved to the bottom. So if I have 2 x's that I'm moving to the bottom, I already had 1 on the bottom. So adding those together, I'd have x to the third. And then you can look at the y to the fourth and y to the sixth as the 4 y's up here would cancel with 4 of the y's in the bottom, leaving me with 2 y's left. And notice I get the same answer no matter which way I do it. It's just a matter of preference on whether you want to think about it as just moving the variables and canceling them, or thinking about it in terms of subtracting the exponent since we're dividing. In my opinion, this way where you're just moving things is easier, but again, it's just a matter of preference. And now in example number 4, we're back to doing the problems with the order of magnitude. It says the order of magnitude of the radius of an atom is about 10 to the 5th times as great as the order of magnitude of the radius of a proton, which is about 10 to the negative 15th meter. What is the order of magnitude of the radius of an atom? So literally this problem says that the radius of an atom is 10 to the 5th times as great as the order of magnitude of the proton, which is 10 to the negative 15th. So we're just going to take the 10 to the 5th and multiply by 10 to the negative 15th. Remember, when you're multiplying things with like bases, you just add the exponent, so I'd have 10 to the negative 10th. Since they left the radius of the proton as 10 to the negative 15th, I'm going to leave the radius of the atom as 10 to the negative 10th, but know that typically you're not supposed to leave negative exponents in your answer, but the radius of the atom would be 10 to the negative 10th, and I guess this would be meters since it was 10 to the negative 15th meters to begin with. So the radius of an atom is 10 to the negative 10th meters long. That's it for this section. As always, jot down anything you don't understand that we can cover in class, so you can be sure to ask me about those things in class. Also, just know that we are going to be taking these sections slow and really reviewing them so that you get all the practice that you need to get really good at this stuff. All of the properties of the exponents and how to deal with them. So, we'll see you in class.